This is what correct voting looks like with 3 candidates. So we just add a 3rd candidate, and this candidate is, as Sarah pointed out, weakly dominated by both candidate 1 and candidate 2. So this candidate is doubly dominated in this way, in the same way that candidate 2 was. And so for each set, so voters will always be presented with candidates in sets of 3 in these groups of 3. And within each group of 3, 1 candidate is a correct vote, and the other 2 are incorrect vote with respect to policy because they're dominated by the other candidate. And so this is what the setup looks like with 12 candidates. There are 4 groups, and in each group the pattern is the same. There's 1 correct vote and 2 dominated incorrect votes. And what this does is, as I explained earlier, allows there to be a baseline of 33% correct voting across all conditions. So a respondent who sees 12 candidates will just see all 12 of these kind of policy combinations. A respondent who sees 3 candidates will be randomly assigned to see 1 of the 4 groups, and a respondent who sees 6 candidates will be randomly assigned to see 2 of the 4 groups. So A and B, A and C, B and D, etc.
So we first ask the voter which are the most important issues, so you rank them, and then you present those voters, those groups, is that?
That's correct. Right, so voters are, that's the next, right, so that's the next step here.
And how do you do that? So, how do you implement that?
So it's computer-based.
Oh.
Right, so I'll explain right now.
You are also assuming that the difference between 1 and 2 is equal to the difference between 10 and 11.
I'm not assuming that. That's an issue that I think we should talk about. If I don't talk about it, remind me. But I'm not assuming that, right?
Okay.
Because that's clearly, that's true, for sure. So, the idea there, well, I guess we can talk about it now. The idea there is that they're clearly not. And so clearly when you have group A, it's an easier choice than when you have group D. And someone who sees 12 will always see a group A. And so they're always going to have the best choice, kind of the easiest choice available to them somewhere there. Whereas somebody in group 1 might not. But I can, because group 1 is randomly getting these pairs, randomly getting one of these groups, and someone who sees 6 is randomly getting 2, I can use that to set a baseline for how difficult this choice is relative to this. So I'll have people who see 3 and make this choice. So I can use that as a baseline, because clearly this is more difficult than that. Sure. It's also worth pointing out that in order to vote correctly, respondents only have to be able to distinguish between the top 7 issues. This is the last difference that matters. So the other ones are just to have some independence between the groups. But they only need to be able to distinguish between issues 1 and 7. 1, 2, 3, 4, 5, 6, 7. So I developed a new web-based survey platform to conduct a survey, precisely because otherwise this would be impossible to make the policy positions a function of the responses. There's something like over 3 million ways to order 12 different policy positions, and so there's just no way to do that on paper. So that was necessary, and so there's some other benefits also that I'll explain in a minute. So how does the survey work? First, after agreeing to participate, people are randomly assigned to see 3, 6, or 12 candidates. They're then asked to rank 12 policy issues in order of importance when voting for a legislator. And then they're asked a set of questions about their age, their income, education, etc. Kind of the covariates that we're interested in, these kinds of things. They're then shown a profile of 3, 6, or 12 candidates and asked to cast a vote. There's no abstention option this year just because I'm worried about losing data. People who don't vote I can't use for this particular question. They're then shown 2 candidate profiles and asked to cast a vote. I'll explain that in a minute. And then finally they're asked a set of questions about their satisfaction with their choice, with the whole experimental setup, with the survey, and then more generally with the satisfaction with elections and democracy. And the idea here is that we know that in a consumer context people are become less satisfied and kind of unhappy oftentimes when they have lots of choice. And so the question of interest here is, as we present them with more candidates, even in this kind of relatively weak treatment, like they're not actually voting and they don't have to deal with these 12 candidates once they finish the experiment, could something even this week lead them to be less satisfied with democracy and elections in general? And so another benefit of the survey, or one of the benefits of the survey, is that it randomly generates the candidate profiles. And so this gets to your question earlier about the profiles being tied to the party affiliations. And so how does this work? What it does is, imagine it's generating the first candidate. So to generate the first candidate, it randomly draws different candidate attributes from a pool of candidate quality, candidate attributes, characteristics. This is like the Mr. Potato Head doll, you know, the cabeza batata de la cabeza, right? So you put ears and nose on it, right? And so there's a pool of names, and for the first candidate, it draws a name, then it draws a photograph, it draws a biography, and then it draws a ballot position. It also randomly assigns the candidate to either be a white male, a black male, or a white woman. and then randomly assigns the candidate to be one of the 12 or one of the 3, one of those issue combinations. Of course, when it's drawing, it draws without replacement. So if it draws a name, it won't draw the name again for the next candidate. Okay, so this is what the 3-candidate ballot looks like. It's pretty similar to last year. It's just a screenshot. 1 white woman, 1 white male, 1 black male, 6 candidates, 12 candidates. The odds of 2 respondents seeing the same candidate is something like 1 in 3 trillion. That's probably not going to happen. So as you can see, each candidate has a little link for biographies and policy proposals, so respondents can click on those links. Anytime they click on any of the links, it opens the policy positions for everyone. So with 6 candidates, if they click on the policy position link, they see a frame pop up on the screen that looks something like this. As soon as the frame pops up, a timer starts, and it observes how much time the respondents spend looking at the policy positions, or how much time they spend looking at the biographies. And so for each candidate, they have 3 policy positions, something like in the previous survey from last year. So there are a number of advantages to using this web-based platform. The first is that it's necessary because there's no other way to make the policy positions a function of respondents' reported preferences. So it's necessary. The second is that it allows me to spend the amount of time, allows me to track the amount of time respondents spend viewing the biographies and the policy positions to see if in fact the information acquisition strategies vary across a number of candidates, or if people are still acquiring information and making some kind of processing error as the number of candidates increases. It also allows me to estimate ballot order effects, the effects of race, and the effects of gender. And the idea here is that because the profiles are being generated randomly every time, in the aggregate, all of the females, say, are statistically equivalent to all the males. And so it allows me to compare the vote share of all the females to all the males, all the black candidates to the white candidates, all the ballot positions, etc. So this is kind of a nice innovation. It's similar to something called component analysis, which is used in marketing a lot of the time. A second benefit is that it allows me to eliminate some of the confounds associated with the candidate profiles. And so, to give you an example, last year one of the candidates, Fernando was a candidate in the 3-candidate condition in the middle, and he was varied. So he became Fernanda, he became Black Fernando, Japanese Fernando, and whatnot. We also had a treatment condition last year with no photos. It seemed like whatever photo we put on Fernando, nobody liked him. He did much better when you couldn't see his face. And so this is kind of an artifact. Who knows why? He had 6 different photos and he did terribly. So maybe we picked wrong. There's just no way to know. But so the software avoids this problem because it's constantly randomly drawing, and so nothing's fixed like that. So I avoid that issue.
So in this experiment, is there a cost of making
There's no.
If I go wrong for figure out and have to step with this guy for 4 years and maybe he may be more policies than not that he didn't want to
Right. No, there's no cost. I have no way to punish voters that much for sure, but not a way to reward or punish too well.
Reward
for a good choice. Right. There's no reward for making a good choice. I know that from conducting the experiment last year and conducting it here this year in person in some places, that people take the choice seriously. So I just know that much, that people do spend time, and I can check through the timers, people spend time considering the candidates and do take their vote pretty seriously. Not everyone, of course, but many people do. So they seem to take the choice seriously. The other response is that across all the conditions, nobody has any incentive to make a good choice. So they're kind of equally incentivized to not take it seriously. So they shouldn't affect the results, but it might lower overall the kind of the strength of the signal, because less people would be taking the question seriously. The final possibility has to do with interaction effects also. And so, say in the case of Fernando and Fernanda, if imagine that a name is fixed to a picture, we assume that the effect is coming from the picture, perhaps it's coming from the name or some other aspect of the profile. And so you can have these strange interactions. Say that Fernando was a sociologist, and for some reason he didn't look like a sociologist when he was Japanese, and so we interpreted that as some kind of bias against Japanese candidates, but perhaps it was a bias against Japanese sociologists or something like that. And so doing this kind of random generation avoids these interaction problems. Maybe that's not a great example, but maybe, yeah.
Why there's no black women?
just have to limit the number of.
Okay.
I'd like to do it, yeah.
And another question, how are you considering the fact that when you have a big number of candidates, you usually vote for the last one you voted for or whatnot? This repetitive game we play in democracy, how is that considered?
So there's no candidates available for re-election. Nobody here has held office, so nobody has the option to do that. It's a very interesting question, actually, about re-election. I haven't found a way to work it into this, but yeah. So I deal with it in that it's not an option for people, but it's clearly I mean, being an incumbent's got to be a much stronger signal than any other signal people are getting here, for example. I think, which might be a good thing because that might reduce the number of correct votes even more. People might just go to the incumbent all the time, and then I'd have no signal or something. But it's a very interesting question. So the last step of the survey is a second round vote choice, and what this does is after people choose in the first round, they're presented with a final choice between two candidates. So they're presented with the candidate that they voted for in the first round, and then one additional candidate from that same group of three that the candidate they voted for came from. And the idea of this is to try to infer correct voting in the first round from voters' choices in the second round. So there's three ways to do this. The first is following law and red laws to say that anybody who changes their vote, changes their mind in the second round, must have voted incorrectly in the first round. So people are saying, you know what, I just looked at these two candidates, I had the choice between them before and I changed my mind. So we can say, well, then you didn't vote correctly the first time around. The second option is kind of a subset of those voters, and these would be voters who in the first round voted incorrectly, but then in the second round changed their vote to a correct candidate. So these would be voters who kind of improved their choice. And so, you know, I could code them as well as having voted incorrectly the first time around. And the final possibility is a separate subset of voters who change their vote. And this would be voters who vote correctly in the first round and then change their vote to vote incorrectly the second time around. So it would be possible to infer that they voted incorrectly the first time around because they've chosen to give up their correct choice. So we can say that, oh, you didn't really mean to vote for that person, you somehow, your correct policy vote wasn't actually intended or sincere. So those are three options for kind of the second round voting mechanism. And then finally, just on survey implementation, the original plan, which failed miserably, was to recruit people here in Brazil at businesses, community centers, internet cafes, and whatnot. And it just is surprising. So I found out quickly within the first week, I was at the USP giving out some flyers with a link to the survey and bonbons to compensate people. And I found that people will take the bonbon, take the flyer, be incredibly gracious and curious, and not do the survey. And there's certainly nothing uniquely Brazilian about that. So that plan failed miserably. And recruiting people in places, so it turns out that people need to be in front of their computer, they won't do it. And recruiting people in volume in places where they're at their computers is surprisingly difficult, at least if you want to get a diverse sample. So, you know, I tried to get into some community centers and things like that, and it proved difficult. So, second option was to recruit people on Mechanical Turk, which is Amazon's crowdsourcing platform. I've done this in the United States. There's been some work on the quality of the sample in the United States. It's quite good. People take the survey seriously. It's inexpensive. It's fast. It's great. But there are very few workers here in Brazil. I've had the survey up for a couple of weeks, and I have 20 responses. There's almost nobody available. And so that's not an option. In the meantime, I've been recruiting voters using email lists from charities here in Sao Paulo. So I've offered charities a donation of R$1 for each person who responds to the survey in exchange for them sending the survey out in their email lists. And people have been pretty responsive to that. I'll show you a couple of results, but it's not really enough subjects to have any great results. So the current plan is to follow Samuel's and Zuko and use some Facebook advertisements to recruit Brazilian voters. There's over 45 million, something like 45 million Facebook users here in Brazil. And so I'm going to recruit voters using an advertisement on the side of their Facebook page, through which they can click, complete the survey, and have me donate R$1 to a charity for their participation. And the surveys, obviously, they're administering it themselves. They're doing it at home.
And this university will be potentially biased against you, because income and education probably greater in Facebook users than people who doesn't use Facebook for this kind of thing.
Yes, I mean, I would definitely have to do some weighting of the sample, but there are maybe not super poor people, but there are poorer people and older people using Facebook, and the number of users is so great that you can still pull a recent sample. The paper is really interesting. It's brand new. It's really a good thing to look at. It's kind of like, I mean, I think the main argument of the paper is this sample is as bad as all the other samples that we use. So it's easy to